Good day and welcome to AFD'S Academy. I'm Efflorescence. Today we're going to be dealing with percentage of water of crystallization and the number of moles of water of crystallization. So when we talk about water of crystallization, we're referring to the amount of water present in a given source sample. So when a source sample contains water in it, we call it, or we tend to refer to it as a hydrated water salt. When there is no water in it, we refer to it as anhydrous. So I'll give us an illustration so that we understand what I'm trying to say. If we have something like this, this is sodium triazocarbonate 4 heptahydrate. It means that this compound contains water in it. Now, the anhydrous part of this salt is this. So I can easily say Na2CO3, this is anhydrous, which means that it does not contain water in it whatsoever. But this side, if I leave it completely, this one contains water. So the formulas which we often use in determining the process of probably the number of moles, which is the X, has to be able to define at the end of the day to give us the number of moles of water present in the salt sample. Let's take, for example, this is our formula first before we start solving questions. So in the formulas, we have the relative molecular mass of the hydrated and the mass conc of hydrated is equals to the relative molecular mass of anhydrous over the mass conc of anhydrous. So if this is our formula, it therefore means that we must, at the end of the day, know the relative molecular mass of the anhydrous, which we must determine. The mass conc of that, we're also going to determine that. The relative molecular mass of hydrated, we also determine, while the mass conc of the hydrated is often given. So, like I said, in this compound, Na2CO3 7H2O, for the hydrated, I will have to look for all of these, which become all of these, which is CO3 7H2O, the relative molecular mass of that, over the mass conc, let's assume is 3, is equals to that of anhydrous. I'll take out this. Over the mass conc, let's say is 4. So this is the anhydrous part of it. This is the hydrated part of it. Whatever it is, that is the relative molecular mass, we are going to determine that from the question that will be given. So by virtue of that, we're going to take our first question so that we'll see how we're going to apply that and know how these things have been solved. So the first question, let me read it out. I say, in a titration exercise, 25 cm cube of sodium triazocarbonate 4X hydrate containing 6.0 gram in 500 cm cube was neutralized by 13.10 cm cube of 0.164 mole per dm cube of hydrochloric acid using methyl orange as indicator. Write the equation of reaction. That is the first question. 2. Hence, we should calculate the mass conc of hydrated sodium triazocarbonate 4, molar concentration of anhydrous sodium triazocarbonate 4, and the value of X. So, like we often do it, we have to list out the given variables. Then from there, we can see what is given, then we'll know what we're dealing with. Alright? So let's take the given. I'll state them out. So I have my given. The acid is, let's call it A for acid, and that is HCl. And our base, B, and that is Na2CO3XH2O. That's number 1. 2, let's say 25 of B. So the volume of the base, VB, is 25 cm3. Containing 6.0 gram in 500. So the B, we have 6.0 gram in 500 cm3. That is of B. Yeah, we understand from our formulas of mass concentration, one of them being mass over volume. Definitely, we'll be able to use this to get mass over volume for the hydrated. So I will put this for hydrated. So let's move on. Was neutralized by 13.10 of 0.164 mole per dm cube of hydrochloric acid. So the volume of the base of the acid is 13.10. So VA is 13.10 cm3. And the CA was given also to be 0.164 mole per dm cube. Good. Using material range as indicator, write the equation of reaction. So our first question was started officially. So these are what they have given to us. We're going to use this to answer the questions that will be required. The first question is, we should balance the equation of reaction. That is number 1. So I can virtually say, for my I, the equation of reaction is HCl plus disodium triiosocarbonate 4 X hydrate. This, of course, they are all in aqueous form. Even if I didn't put that, you should know. So I have my metallic part here is sodium going reacting with the non-metallic. So I have my sodium chloride plus the hydrogen and the carbonate. So we have hydrogen carbonate left. When you decompose that, you're going to have water plus CO2. But there was also another water here, so that is plus X water. So with this, we can now balance, but this is the format which we have. So let's say we have 2 sodium, but here we have 1. Chlorine is 1 here. So if I must put my 2 there, I should also put 2 here. So I will now have this. Sodium 2, so that is balanced. Chlorine is 2, chlorine is now 2. Let's look at the others. Hydrogen is 2 here, hydrogen is 2, and this other hydrogen X is also 2. So hydrogen is balanced. We look for oxygen. I have my 3 here, 2 plus 1, 3, aside the water on, so our equation is balanced. So from this equation of reaction, we have Na, number of moles of acid, becomes 2. And the number of moles of base becomes 1, because here it's 1. So it's important, if we are unable to balance our equation, we cannot get the answer correctly. It's part of the whole thing. So the number 2 question says that we should calculate the mass concentration of hydrated sodium triiosocarbonate 4. Now, this is the hydrated. It contains water, but we don't know the number of moles of water yet, which I know they will ask us to determine. Now, they are asking us to get the mass concentration. What can we do here? We have formulas for mass concentration to be molar count times relative molecular mass. The molar count here is not given, and the relative molecular mass is not complete because this is not known. The X is unknown. So, but we also have another formula for mass count to be mass over volume. So this can go for hydrated. So let's take our second question. 2. Mass count for hydrated salt or base, hydrated B, is equals to mass in gram over volume in dm3. And this is, the mass is given to be 6.0 gram and the volume is 500 over 1000. We are converting to dm3. And this is 6.0 gram over 0.5 dm3. And this is, so we're going to find out what that is. 6 divided by 0.5 will give us 12 GDM3. So we have 12 GDM3. So this is now the mass concentration of the hydrated B, sodium triacylcarbonate for X hydrate. So I'll put here saying GDM3 of hydrated B, hydrated, is 12.0 GDM3. The GDM3 means mass concentration. Because of space, I always prefer to use GDM3. Now we've taken the second question. Let's look at the third. They say the molar count of anhydrous. So we're going to solve that of anhydrous, which means when you cut this out, what is left is anhydrous. They are asking for the molar concentration of base. So permit me, let me take this one out. So, okay. Molar count of anhydrous B. So let's call that, I don't know, that's 3. Molar count of anhydrous. Now for us to get the molar concentration of the anhydrous, we are going to use the CAVA formula. We have a lot of formulas. We have that of mass count over relative molecular mass. But the relative molecular mass is here unknown, so we can't use. Perhaps they say anhydrous, which means we are cutting this out. So we use the CAVA. Now, are the variables for CAVA complete? Yes, we have VA, CA, NA, we have VB, NB. So it's just CB that is left. So we can use that formula. And the formula is CAVA over CB, is equals to NA over NB. So if I want to make my CB the concentration of the base, the subject, I will now have my CB is equals to CAVA NB over VB NA. And this is equals to, the concentration of the acid is 0.164 mole per dm3 times the volume of the acid is 13.10 cm3 times number of moles of the base is 1 all over the volume of the base is 25 cm3 times number of moles of the acid Na is 2. And this is equals to 0.164 times 13.10 divided by 50. 0.0430. 430. 0.0430. 0.0430 mole per dm3. So now we've gotten the concentration of the base. So I call this CB, which is 0.0430. 0.0430 mole per dm3. So gradually we're getting the variables and we move on. Now, we've gotten the molar count of the anhydrous. Now, the value of X. For us to get the value of X, I have to bring in the formula fully for water of crystallization. Let's see how that can be gotten. Now, if the formula says that relative molecular mass of the hydrated, which is all of it, that is where X is, over the mass count of the hydrated, which is, we got that here, 12. Over the relative molecular mass of the anhydrous, we can get this from here. But the mass count of the anhydrous we don't know. So we must determine the mass count of the anhydrous first before we can apply the formula. So let us determine the mass count of the anhydrous first before I can put in the formula or substitute into the formula. So I will call that 4, which is mass count of the anhydrous B. So my 4 now is mass count of anhydrous B. So for us to do that, I'll call it my mass count of B is equals to the molar count, which we just finished getting it. Molar count of B times the relative molecular mass of anhydrous B. So this is the molar count was 0.0430 mole per dm cube times the relative molecular mass of sodium triisocarbonate 4 is about 106 g mole. How do we get that? So I can easily check that out. Here is 23 times 2 plus carbon is 12 plus oxygen is 16 times 3, which is 48. So this is 46. Alright, 46 plus 12 plus 48. 40, 40, 80. 90, 100, 106. So that's how we got this, 106. So when we multiply this out, we're going to have, okay, so we have 4.558. So this is 4.558. So let's call that 56 dm cube. Now, this is the mass concentration of the anhydrous, sorry. It's meant to be smaller than the mass concentration of the hydrated. That of anhydrous must be smaller than that of the hydrated. Because here there is still water, so it will increase, but here the water has been removed. Therefore, I can easily say GDM cube of anhydrous is 4.56 GDM cube. That's the mass count. So, let's proceed. Now we want to calculate the value of X. That is what they are asking us. The value of X, and hence the percentage of water of crystallization. For the value of X, this is what we do. I'm going to take out all of these so that I can bring in the value. Here is the value of X. For us to get the value of X, we put in our formula, which is relative molecular mass of hydrated, which is Na2CO3X water, over the mass count of hydrated is 12.0. Let's leave it. Let's forget the unit for now. Over relative molecular mass of anhydrous, which is Na2CO3, over the mass count of anhydrous is 4.56. So if I should get the values right correctly, this is 106 plus x18 over 12 is equals to 106 over 4.56. Now, how did I get 106? The relative molecular mass, 23 times 2 plus 12 plus 16 times 3 will give us 106 plus 18. 16 oxygen has a relative molecular mass of 16 plus 2 will give us 18. This is equal to 106, which is this, over 4.56. So now we have to make X the subject of formula. So I'll continue to clean. I don't think I need more of this. So let's come back here. Now I want to make this a subject. This is what I'm looking for, so I multiply this side first. So I have 4.56, which is this, times this, 106 plus x18 is equals to 12 times 106. So 4.56 times 106 first. 4.56 times 106 is equals to 483.36. 483.36 plus 4.56 times 18. 4.56 times 18 is equals to 82. So we have x 82.08. This is equals to 12 times 106 is equals to 1272. 1272. So from here, we collect like terms. So I have x 82.08 is equals to 1272 minus 483.36. Now I'm going to have my x 82.08 is equals to 1272 minus 483.36. I will have 788.64. So when I divide by 82.08, this will go and my x become this divided by this, divided by 82.08 will become 9.6. 9.6. So x approximately is 10. So we've been able to get the number of moles of water of crystallization. What did they say? They say the value of x, which we have gotten, and hence the percentage of water of crystallization in sample B. So we've gotten the value of x. Now, if we were to substitute this into the formula, we're going to be having something like Na2CO3 10H2O. This is sodium triacylcarbonate 4-decahydrate because the number of moles of water of crystallization are 10. You may be asked to give the name of the compound, but for the time being, that is what it is. So we've gotten that our x is 10, and the next thing they are asking us to do is to get what? The percentage of water of crystallization. We want to know the quantity of water present in the sample, because in water of crystallization, the amount of water in the hydrated salt does not participate in the reaction. So we have to determine through calculational principles to know the accurate value of x in the whole thing. So let's proceed. Now let's determine the percentage of water of crystallization. Remember, we are having 10 now. Now this is what we have. Water, we have x water for the percentage. Let me call that, is it 5 or 6? Okay. Percentage of water of crystallization. Will become, the percentage is x water over the whole compound, which is Na2CO3 x water, times 100. X water, the X is 10. So 10, open bracket, this is 18 over, this is 106 plus 1018 times 100. So that becomes, this is 180 over 106 plus 180 times 100, which is, so I have 106 plus 180 is 286. So 180 over 286 over 286 times 100. That is 62.9%. So we have 62.9%. So the percentage of water of crystallization in the source sample is 62.9. Now, alright, our second question. We say solution A contains 20 grams of ethane dioxide acid crystals in 1 dm cube of the solution. The crystals means that of the hydrated. Now, solution B is a solution of sodium hydroxide containing 0.5 mol per dm cube. If 41.63 cm of A, that is of the acid, react with 25 of B, calculate concentration of A in mol per dm cube, number of water molecules in 1 mole of ethane dioxide acid crystals, that is the value X, percentage by mass of water of crystallization. So let us list out the given. We have our A for the acid that says ethane dioxide acid H2C2O4 X water. Okay. And B side is sodium hydroxide. See, A contains 20 grams of ethane dioxide acid crystals in 1 dm cube. So that is the mass concentration of the hydrated ethane dioxide acid. So I can easily say mass form of hydrated A is 20.0 ggmp. Solution B is a solution of sodium hydroxide. It contains 0.5 mol per dm cube. This is a solution of sodium hydroxide containing 0.5 mol per dm cube. So concentration of the base is 0.5 mol per dm cube. If 41.63 of A, the volume of the acid, is 41.63 cm cube of A, react with 25 of B, volume of the base is 25 cm cube. Calculate concentration of A, number of moles, and the equation of reaction is given to be H2C2O4X water plus 2 sodium hydroxide, which gives us Na2CO3 plus 2 moles of water plus X water. So this is what we have. So from here, we will be able to get the number of moles of the acid and that of the base. So here I have my number of moles of base is 2. So I have 2 here. And number of moles of acid is 1. I have 1. That is the reason why equation of reaction must either be given or you balance it. Either way, if they don't give you, you balance. They give you, you thank your stars. So from here we're going to proceed by solving the basic question which they required of us. The first one they say concentration of acid in mole per gn cube. So we want to begin with that. For us to get the count of the acid, we have the count of the base, volume of the base, number of moles of the base, number of moles of acid, volume of the acid. The only thing that will be short or that is missing in order for us to use our CAVA is the CA. So if we use CA, we're going to get that appropriately. Otherwise, if we use any other formula, for example, mass count over relative molecular mass, we don't know X, so that formula will not work. And perhaps this is for the hydrated. So let's proceed. For us to get the molar count, 1. Molar count of A. We use the formula CAVA over CBVB is equals to NA over NB, where we're looking for CA, where CA is equals to CBVB NA over VA NB. When this is true, this becomes CB, the concentration of the base is given to be 0.5 mole per gn cube. So I have 0.5 mole per gn cube. Volume of the base is 25 times number of moles of the acid. Na is 1. This is over volume of the acid is 41.63 times number of moles of the base is 2. So, and this is equals to CA, which therefore becomes, I have my 0.5 times 25 is equals to this, divided by 41.63. So divide by 2. We have 0.150. So this is 0.150 mole per gn cube. So we've gotten the molar count of the acid, which is Ca is 0.150 mole per gn cube. Now, question 1 solved. 2. They say we should get the number of water molecules in 1 mole of ethane diol acid. They are going straight up to tell us to get the number of moles of water, which is X. And for us to get our number of moles of X, we have the mass count of the hydrated. We must also get the mass count of the anhydrous. That is when we can make use of that formula. So, clean the board. Let's calculate the mass count of the anhydrous. Mass count of anhydrous A will be, the molar count times the relative molecular mass of A. The molar count is 0.150 mole per gn cube times the relative molecular mass of this is 90 g mole. So if you do that, there is hydrogen 1 times 2 plus 12 times 2 plus 16 times 4 will give you 90. So this is equals to 0.150 times 90 will give us 13.5. So here I have 13.5 GDN cube. So the mass count of anhydrous is 13.5 GDN cube. Now to get the number of moles of water crystallization, let me take this out, which is X, the value of X. So we say, to get the value of X, we say the mass count or the relative molecular mass of hydrated, which is the relative molecular mass here is 90 plus X18 over the mass count of hydrated, which is 20, is equals to the relative molecular mass of anhydrous, which is just 90, over the mass count of anhydrous, which is 13.5. So let's cross multiply. 13.5 over 90 plus X18 is equals to 20 times 90. So we're going to begin. 13.5 times 90 is 1215. 1215 plus 13.5 times 18. 13.5 times 18 is 243. Okay, 243 X. Okay, let's proceed. This other side is 20 times 90. 20 times 90 is 1800. 1800. So I have my 243X is equal to 1800 minus 1215. My X is equal to, now I have 1800 minus 1215 is 585 divided by 243 divided by 243 is 2.4. 2.4. So the number of moles of water of crystallization in this sense is 2.4, which definitely means that this is ethane dioxide dihydrate. If I put it 2 here, it becomes dihydrate. So many times the ones you may be encountering, they may ask you to tell us the name of the compound. So when you're done getting your X, you substitute it into the formula and you tell us what it is. So for the time being, you take note of that and don't forget. So that is 2.4. Now we're going to get the percentage of water of crystallization. How do we get the percentage? We will take this out to bring the formula therein. So for the percentage, we say for the percentage is equals to water, which is X18. Let's call it X18. Or let's leave it X water over the whole compound, which is H2C2O4X water times 100. So the X is now 2.4 open bracket 18 over 90 plus 2.4 open bracket 18 times 100. And this is equals to 2.4 times 18. We'll be having 2.4 times 18 give us 43.2. 43.2 over 90 plus 43.2 times 100. And this is 43.2 over, okay, now we're going to add the downside, which is 43.2 plus 90 give us 133.2. 133.2 times 100. So finally the percentage becomes 43.2 times 100 is equals to this, divided by 133.2, and that is 32 point, and this finally the percentage is 32.4. So this is the percentage of water of crystallization in ethane dioxide dihydrate. We're going to take more questions. Let's take question number 3. If we can solve like 4 or 5 questions, I believe that will be enough for anybody who want to go through it to be able to get what you want in terms of references. So let's proceed. Provided with 2 solutions, A and B. A is a solution containing 0.10 mole per dm cube triazonitrate acid with a volume of 12.90 cm cube. B is a solution of anhydrous triazocarbonate 4 salt, okay, with 25 of volume. The equation of reaction is given to be this. From the equation of reaction and the information provided, calculate the concentration of B in mole per dm cube, concentration of B in GDM cube. Given that B contains 3.6 grams of the hydrated sodium triazocarbonate 4 salt in 500 of solution, calculate the percentage of water of crystallization. So we're still going to list out the given variables so that we'll be able to know exactly what we're doing. So let's take that. This is our A. Let's say is HNO3. Okay, A and B. A, it contains the concentration of the acid here is 0.10 mole per dm cube. Alright. With a volume of 12.90. Volume of acid is 12.90 cm cube. B is a solution of anhydrous triazocarbonate 4. Anhydrous triazocarbonate 4. So, okay, this is B, anhydrous. So Na2CO3 does not contain water in it. Let's see where the water is going to come. Alright. And the volume of the base, VB, is given to be 25 cm cube of volume. The equation of reaction is given to be 2 moles of HNO3 plus Na2CO3 give us sodium nitrate plus CO2 plus water. So from the equation of reaction, the number of moles of acid is 2 and the number of moles of base is 1. Alright, now we say we should calculate the concentration of B in mole per dm cube. Concentration of the base in mole per dm cube. They've given us that of the acid, so we need to get that of the base. So we have virtually almost everything we need. So let's see what we can do. We're going to take this out. So number 1, count our B in mole per dm cube means the molar concentration of the base. So we can use this formula then, CAVA over CBVB is equals to NA over NB. We're looking for CB, so my CB is equals to CAVANB over VBNA. And this is equals to, the CA is given to be 0.10 mole per dm cube times volume of acid VA is 12.90 cm cube times number of moles of base is 1. This is equals to the volume of the base is 25 cm cube times number of moles of acid Na is 2. So this is equals to my 0.1 times 12.9 divided by 50. 0.0258. 0.0258 mole per dm cube. So we have the concentration of the base now. Cb is 0.0258 mole per dm cube. The next question says the conc of B in GDM cube. So the conc of B in GDM cube, that's a good lot. Okay, this is the B which we've gotten. The GDM cube of B becomes the molar conc times the relative molecular mass. So let's go further. I'm going to take this out so that we can bring that in. B. So we say the conc of B in GDN cube, which is the mass concentration, and that is equals to molar conc of B times the relative molecular mass of B. So the molar conc of B, which also got out to be 0.0258 mole per dm cube, times the relative molecular mass of this is 106 g mole. So this is going to be 0.0258 times 106 is equals to 2.73 GDN cube. So this is for the anhydrous. They've not asked us of the hydrated here. We'll see where that is going to come. So we've gotten that. So I can easily put it here. The GDN cube is 2.73 GDN cube. Now, next question. Permit me to take this out. The next question says, given that B contains 3.60 gram of the hydrated sodium triacylcarbonate 4, so what we got was that of anhydrous, and they are giving us variables for the hydrated, which wasn't from the initial question, but it is being incorporated. Somehow we understand. So if B is 3.6 gram of the hydrated sodium triacylcarbonate 4 salt in 500 cm of solution, we should calculate the percentage of water of crystallization. Before we proceed to do the percentage of water of crystallization, we must know the mass concentration of the hydrated, which there says 3.6 in 500. So I will say mass conc of hydrated. Okay, just understand mass of hydrated or mass conc of hydrated is equals to mass in gram over volume in dm cube. And the mass in gram is 3.60 gram over 500 is 500 over 1000, which is 0.5 dm cube. And this is 3.6 gram over 0.5 dm cube. And this becomes 3.6 divided by 0.5. That is 7.2. It has to be higher. That's correct. 7.2 GDN cube of hydrated B. So for hydrated, GDN cube is 7.2. Now, for us to get the, what did I say? The percentage of water of crystallization, we must get the number of moles first. So sometimes the question is not just direct. You have to use your senses to understand what you are doing. They are asking us of percentage. Meanwhile, we have to get the number of moles of water of crystallization before we can get a percentage. Just like we understood that we must have to get the mass concentration of the hydrated before anything else. So we'll proceed, and they never asked us to calculate this, so we know that. So let's get the number of moles before we can go to the percentage. Number of moles of X. Guy, you can come inside too, but stay quiet. Now, for us to get the number of moles for water of crystallization, we have the relative molecular mass of this. Let me write it for the sake of knowledge. Over the mass count of the anhydrous. I'm starting from the anhydrous now. Anhydrous is 2.73. Is equals to the relative molecular mass of hydrated X water, which came in the later part of the question. Remember they said the last, given that B contains 3.6 of the hydrated sodium triacylcarbonate 4. So that is a part of it. And this is 7.2. So I'm going to find out that this is 106 over 2.73 is equals to 106 plus X18 over 7.2. If I have to make my X the subject, so this is going to come with this and this go with it. So 2.73 open bracket 106 plus X18 close bracket 106 times 7.2. Okay. Let me take all of these out so that I can take them to the upper side. Okay. From here, I have this. Let's proceed. 2.73 times 106 is 289.38 plus. Oh, okay, thank you. 38 plus 2.73 times 18, 49.14. This is equals to 106 times 7.2. 106 times 7.2. That gives us 763.2. 763.2. So, if that is true, I just going to take this out. Done with this. Okay, from here, this is X. Sorry. I make this the subject. X 49.14 is equals to 763.2 minus 289.38. Now my X is equals to the value of that is not mine. 763.2 minus 289.38 divided by 49.14. 9.6. X is 9.6. Therefore, if X is 9.6, which is approximately 10, we can say that the compound is sodium triacylcarbonate 4 decahydrate because it contains 10 moles of water. So finally, what they ask of us is the percentage of water. Now, I forgot the number. Now, percentage of water of crystallization become water, X water, over disodium CO3X water times 100, which is equals to X is 10. 10 times 80 over 106 plus 180 times 100. 106 plus 180. 106 plus 180 is 286. 3 approximately, or 62.9. So the percentage is 62.9 or 63%. The answer seems similar to what we've done before. Let's proceed. Let's take our fourth question. I don't know, maybe we should solve like 4 or 5. We're going to be good with that. Okay, our next question before the let me clean the board. Alright, the question says, some crystals, let me see, of washing soda, blah blah blah. Some crystals of washing soda were exposed to the atmosphere for efflorescence to take place. 6.02 grams of this partly efflorescent washing soda were then dissolved in 500 cm of water. Okay. 25 of the triisoocarbonate 4 solution required 32.10 of 0.097 mole per gn cube hydrochloric acid, HCl, for complete neutralization. Calculate Y. Hence, write the formula of the efflorescent washing soda. So it's a direct question. They just went straight that we should find our Y. Y is the number of moles of water of crystallization. They did not tell you to calculate the mass concentration, the molar count, all of those stuffs are there. But they just believe that if you know the formula, you can move straight, you know how to find your way through to the bottom of the question. So let's see how we're going to get that done. We are given, our normal given is our A and our B, the acid and the base. So, some crystals of washing soda were exposed to the atmosphere for efflorescence to take place. And we have, that is, that is sodium triisoocarbonate 4x water. And for that to take place, we have 6.002 grams in 500 cm3. When they dissolved in 500 groups, 25 of this triisoocarbonate 4, volume of the base is always 25 cm3. Require 32 of A. Acid, volume of the acid is 32.10 cm3 of A. And A is HCl. And A is also Ca is 0.097 mole per gn cube. For complete neutralization, calculate Y. Hence, write the formula of the efflorescent washing soda. Now, the efflorescence, now, it is a sample, a hydrated sample, which was exposed for some water to lead it to efflorescence. But then we understand that to be that of the hydrated. We're going to look for that of the mass of the hydrated, which is, we know from here, which is mass over volume, we can get out of the hydrated. Now, but for us to do anything, we first balance the equation. In this case, they did not give us. So we don't know. You may tend to encounter those that equation of reactions are not given. So you're meant to balance them in such situations. We have our HCl plus sodium triisoocarbonate 4x water give us our sodium chloride plus water plus CO2 plus X water. Let's get to check if it's balanced. We have 2 sodium, we have 1. So if I put 2 here, I can put 2 here. I have 2 sodium now. Chlorine is now 2, chlorine is 2. Water is 2 hydrogen, 2 hydrogen. I think it just is balanced. So by virtue of that, we have an Na is 2. Our Nb is 1 from here. Then we can proceed to get whatever they want us to do. They say we should get the value of X. Now, there are other things we need to do. For us to get the value of X, we must get the mass concentration of the anhydrous, we get the mass conc of the hydrated, we get the molar conc of the B. So let's begin with the molar conc because the variables here are pointing to that. So let's begin. I'm going to take this out. So question number 1, all of these questions we want to solve, they didn't ask us, but we understand that these are the things we need to get our Y. Aside that, we are going nowhere. Oh, they gave us Y. Sorry, I'm putting X. I'm soon becoming useful. X. I think so. Let me be sure what they asked us to do. Okay, I think it's Y. Calculate Y. That is true. So let's proceed. C molar conc of the base. So we use, for us to get the molar conc, okay, let's say for molar conc of B, we use the formula CAVA over CBVB is equals to NA over NB, and we're looking for CB, concentration of the base, because that of the acid is given. So CB is equals to CAVA NB over CB, okay, sorry, looking for this, over VB NA. And this is equals to, CA is 0.097. 0.097 mole per dm³ times volume of the acid is 32.10 cm³ times number of moles of the base is 1. Volume of the base is 25 cm³ times number of moles of acid is 2. So we move on to check this out. We have 0.097 times 32.10 equals to this, divided by 50. We have 0.0623. This will give us 0.0623 mole per dm³. Okay, good. So now we have the conc of the base. So I have my CB now to be 0.0623 mole per dm³. That's number 1. Number 2, we've gotten this, so we need to get the mass conc of anhydrous B. So I want to take this out so I can calculate that. Mass conc of anhydrous B is equals to the molar conc of anhydrous B times the relative molecular mass of anhydrous B. And the anhydrous B is this. The molar conc, we just got that to be 0.0623 mole per dm³ times the relative molecular mass is 106 G mole. So this is 0.0623623 times 106 equals to 6.604. 6.604 GDM³. This is anhydrous. So the first GDM³ here, 6.60, or let's just call it 60, 3 significant GDM³. Now that of hydrated, 3. Mass count of hydrated is equals to mass in gram over volume in DNQ. And the mass in gram is given to be 6.02 gram over 500 divided by 1000 is 0.5 DNQ. And this is equals to 6.02 divided by 500. Oh, sorry, not 500. 6.02 divided by 0.5. This is 12.04. This is 12.04 GDNQ. So this is for the hydrated. For the hydrated is 12.04. Now let's get our value Y. Y, which is relative molecular mass of hydrated over mass count of hydrated over equals to relative molecular mass of anhydrous over mass count of anhydrous. This is hydrated anhydrous. So let's proceed to get the value of Y. Now, to get the value of Y, what do? We say the relative molecular mass of hydrated, let's start with hydrated, which is 106 plus Y water, Y18, let's call it 2. Over hydrated, the mass count is 12.04. Is equals to the relative molecular mass of anhydrous, which is 106, over the mass count of anhydrous 6.60. So we're going to make Y the subject, so this multiplied by this, 6.60 open bracket 106 plus Y18 is equals to 106 times 12.04. So this will be 6.6 times 106 is equals to 699.6. 699.6 plus 6.6 times 18, 118.8. X 118.8. This is equals to 106 times 12.04 is equals to 1276.54. Good. So from here, this minus this divided by this. I don't have much space, so I want to get my answer. So I have 1276.24 minus 699.6 equals to this divided by 118.8, and that is 4.8. So my x is equal to 4.8, which approximately is 5. What did I say? Write the formula, no. Hence, write the formula of the Efflorescence washing soda. So the final section, you've gotten your Y to be 5, and they're asking you to write the formula. For us to write the formula, this becomes Na2CO3-5H2O. So this is disodium triazocarbonate 4 pentahydrate. That is the formula and that is the name. So we're going to take the last question as assignment. Yes, or a test. Let's test ourselves to see our ability, because what we just solved is very similar to what is given. Technically, almost visual everything. Oh, all right. Let's see that. When you're done, you go to the comment section, upload your answer. Let's see if you're correct. Then we can proceed from there. So the question says, some crystals of washing soda on exposure to the atmosphere effloresce 5.88 gram of this partly effloresced washing soda, sodium triisocarbonate 4X hydrate, were then dissolved in 500 of water. 25 of this triisocarbonate 4 solution require 30.0 cm³ of 0.1 mole per dm³ hydrochloric acid for complete neutralization reaction. Calculate X and write the formula of the fluoride salt. So virtually almost everything is the same. In the other one is 6.02 grams in 500. Here is what they call it, 5.88 grams in 500. So I believe the answer will be closely related. So by virtue of what we've done justice to everything that pertains percentage of water of crystallization in terms of solving it. The formulas required. The style also is very. Sometimes they're going to ask you to calculate the number of moles of water of crystallization, or which could be X or Y, without telling you to do any of the mass concentration of the hydrator or mass concentration of the anhydrous. They wouldn't tell you that, but you would know. But if you are attentive, you pay attention vividly to what we've done, you're going to do justice to that. So I will advise you, you go through our videos in order to get yourself in tune with what we're doing and in alignment to the chemistry of the day. And do not forget to subscribe and like the video when you go through it. And also in the comment section, you comment to tell me how it is with you when you go through it. Do have a wonderful time. I see you again. Bye.